This
account.
conference will now be recorded.
Okay. Hello, everybody. I want to say hi. Thank you very much for coming to this virtual session for community ambassadors and taking the time to join us to learn about our construction project. I am Michelle Capizella. I'm the library director, and I'd like to introduce our trustees of Mahopac Library who are joining us. We have Joe Tock, we have Stephen Baranowski, we have Eugene Bosch, we have Joe Montori, and we have Frank Del Campo, who is the president of the Board of Trustees. So Frank, you want to say a few words?
Sure, I'll be brief but important. Thank you, all of you, for listening in and asking the critical questions. And we hope that the facts that we give you tonight with our architect and our general contractor will give you the information you need. So I appreciate these professionals coming, and I appreciate my board taking time out of their busy day to sit here and prepare this. But I want to also turn it over to Joe Montori, who was the chairman of this advancement committee, who's done quite a bit of work with Debbie, who's hiding somewhere in this meeting, recording it and working with the minutes, I'm sure. Thank you, Debbie, for all your work in writing these letters. And one of the things she did for me, will be going with hopefully some board members maybe, as well as Michelle maybe, on the 5th of April to the chamber board, 8-member board. And I'll report at our meeting so we don't waste too much time tonight. My conversations with the 2 CEOs of the chamber, who are very positive about getting the facts out so people are prepared to vote appropriately. So I'm not going to spend any more time, but thank you all for taking this time. And we thank our patrons who may be listening for the way they come to our library and make it a great institution in our community that it is. I'll turn it over to Joe, our chairman. Joe.
Thanks, Frank. Just very quickly, thanks to everyone who accepted our invitation, and we look forward to talking with you. If you have questions, by all means, reach out to Michelle or any of us. You'll be receiving a brochure in the mail and a bookmark as well, with a themed for our building renovation work. And if you have any organizations that you are a member of that might be interested in hearing about this project, please reach out to one of us, and because we'd love the opportunity to connect with them and share this news with them as well. And finally, don't forget to vote on June 7th in our board election, and of course for the bond referendum. Michelle?
Okay, I'm going to just start, just do a brief kind of a history of how we got to where we are, and when we first realized that there were, came to realize that the issues in the building, that we needed to kind of do some further investigations. So on January 5th, 2016 is when we had a sprinkler pipe that burst in the attic, and it was on the lakeside, and it caused $93,000 in damages. So we went to our insurance company, and we wanted to, of course, when something like that happens, you want to mitigate any further issues. So we had the attic insulated. They put closed cell fire rated foam insulation in February 2016. They went through and they did any leaking beam, ceiling, and wall joints. And we also had the attic heater, which we found out was undersized. We had that replaced so we would get more heat up into the attic. So we were hoping that that was going to solve our problems. So in February 2018, we engaged Tetra Tech architects and engineers to evaluate the building and draft a facility plan. And we needed a board approved facility plan if we were going to apply for any construction funds. So we had them come in, and during their investigation, they started noticing some significant issues with the building envelope, and they recommended that we do further studies that would require special equipment and some demolition and engineering analysis. So these included a thermographic study to determine where insulation might be lacking, and a testing, adjusting, and balancing analysis to pinpoint any deficiencies in the building that could affect the performance of the HVAC, which is our heating, ventilation, and air conditioning system. So we formed an ad hoc committee of the board, and they reviewed the results of the facility plan, and we consulted an outside engineer, and it was determined that the evaluation of the HVAC system was really what we needed to make a priority. So in February 2019, we brought in OLA Consulting Engineers to perform a detailed survey of the HVAC system and controls. And their findings were that the library, they thought we should continue and go and have an assessment of the building envelope. In the same month, we had another sprinkler pipe burst. So that's in February 2019. This time it went to the 3rd floor. So that's when we were kind of realizing that we thought we had, by insulating the attic, we thought we had solved the issue. But obviously now that it's moved down to the 3rd floor, that kind of cemented the fact that we had more significant issues. In November of 2019, River Architects came in and performed a blower door test, which is used to determine how much air is entering or escaping a building. And they took some infrared images before and after the blower test. Then in January 2020, they returned to conduct investigative probes in areas of particular concern. And so that's kind of cutting holes in the walls to kind of look and see what's behind them to kind of determine what might be, what's there and what might be missing. And those 2 tests, the blower door test and the probes, revealed major issues with the building envelope, including many areas of missing insulation. So just kind of we knew that there were issues, and one of some of the things that we were doing to mitigate these issues were during the months of November through March, we kind of push up ceiling tiles in the I have one up here that's open in the different areas on the 3rd floor to kind of let warm air from the building up into the areas above the dropped ceiling, so that way we don't have any more sprinkler pipe bursts. We increased the building temperature to 72 degrees, so kind of mitigate the loss of any heat that we have. And since we're on Lake Mahopac, that makes it, when it's cold, it's really a lot colder than the winds off the lake are much colder than they would normally be. When it's really cold out, the HVAC is run 24/7 for the nights that it's going to get really cold. So the HVAC system is working overtime, and it's to compensate for the effects of the limited insulation. And because of that, we're going to have greater wear and tear on our equipment. I also, during July and August, when we're closed on Sundays, I still run the HVAC to prevent the building from becoming overheated, because we lose a lot of the building is leaky, so we get more heat in. So as a result of one of the things that happened as a result of all of the claims that we had for the water damage of the burst pipes, our insurance carrier, who's Utica National, in June of 2020, they dropped us. They didn't renew our policy. So our insurance broker went out, and she was looking for a replacement carrier, and the only one that there was one carrier that was willing to accept the risk, and it increased our premium from $25,000 to $75,000 a year. So we're actually paying about $50,000 more in building insurance per year, just because of some of the pipe bursts and the claims that we've had. So with knowing, after we found out like really everything, the magnitude of the problems that we were having, the Board of Trustees consulted the Mahopac School District for recommendations, and we were referred to the Palumbo Group. and Bob Palumbo is joining us today, and they specialize in construction management and general contracting. And during August 2020, Bob came in and he visited the library several times, once with an insulation contractor, and he presented us with a line item budget at our October 2020 meeting. So the board, once again, after that, just to ensure that public funds are spent responsibly, the board once again went to consult with Tetra Tech for recommendations on how to approach this insulation project. And after the results of the diagnostic tests, Tetra Tech proposed addressing the mechanicals as well as the insulation. And they presented a proposal that was accepted at the board's April 14th, 2021 meeting in the amount of $3,154,283. So what I'm going to do now is I'm going to introduce Christopher Glaubitz, who is from Tetra Tech, Architects and Engineers, and also Robert Palumbo, who is from the Palumbo Group. They're going to talk a little bit about the scope of the project and some of the findings, and just so you kind of get some information on what we're doing. So do you want to start, Chris?
Sure. Thanks, Michelle. And Bob, jump in, when you want, if you want to say something. And but I'll just kind of run through the scope of work. And as Michelle said earlier, the majority of what we found and what we want to address has to do with the building envelope. And by building envelope, we mean walls, ceilings, roof, and in this case, particularly the thermal envelope. And so one of the things that modern buildings typically do much better than the Mahopac Public Library is doing right now is control thermal transfer, right, from the inside to the outside. So Michelle was talking about she's got to run the HVAC system like all the time to keep up with it, because we found that there are some areas of the building that were not insulated properly. Another thing that modern buildings do is to keep airflow, regardless of heat, to keep airflow also under control. And that's also something that we found, and Michelle can probably attest to this. There are areas in the building where you can stick your hand above the ceiling and you can feel air flowing. Sometimes when you open the main door, you can feel that air sort of flowing in. So one of the things that we discovered was that the building is sort of acting like a chimney as air warms naturally from being inside the building, like in the winter time, in the heating season. And it's finding ways out the top of the building, and so that then pulls new colder air in the bottom of the building, and you have a bad cycle. So when I go through the scope of work, that you'll see that most of the items on there are intending to address those factors that we feel are the biggest factors. There are also some mechanical system, I'll call them tweaks, because the mechanical system, some changes have been made over the years in order to try to compensate for, what the mechanical system was having to do to, sort of fight the good fight of trying to keep the building warm in the winter and cool in the summer without proper insulation or air barriers. So with that, we'll just kind of run through quickly, and if anybody wants to jump in and have me expound on anything a little bit more, I'll please do. I'll just kind of go through them quickly so folks understand the work that we're talking about. So we started kind of outside. There's a little bit of pavement and sidewalk work, just to solve some areas where the original paving catches some water and it can sit there. So we're just doing some regrading to take care of that. In the winter, it can freeze, and that can be a safety issue as well. So that's those first couple items. We saw some efflorescence, which is when you look at a brick building, something made out of masonry, you see that white, sort of a white surface on there, and that basically means that water is coming through the wall and it's coming out of the wall, and that's the salt in the water that's left on the wall. So we saw that on some of the brick garden walls. So we're going to address that issue and do some work to just help keep the water out of those walls and keep them in good shape, because when that water freezes and thaws, that can destroy a wall. There was a little bit of elevator work that we had in the scope that I think we're gonna, it's very minor, and I think that's gonna be something that can be taken care of by the elevator maintenance company. Some of the studies that we have in here, like this one, which is number 25, was to get a little bit more information to confirm how the building and the walls were actually built in a couple specific spots. So we were looking at the sheet sort of barrier that that serves as an air and vapor barrier. In the case of this building, it was the sort of asphalt building felt paper. So there was a little bit of investigation to take off a couple bricks and peek in there and see how things were put together. They're going down the sheet a little further. There's some more efflorescence and mortar just around the building, just fixing up some of those mortar joints. As far as energy efficiency, the last item on this sheet, it is really going in from the inside of the building, since you have a stud wall with sheetrock on the inside, removing some of that sheetrock and getting some insulation into that stud cavity space where it should be, but is not currently. So that's what that last one is about. Try to improve your thermal envelope of the building. So Michelle mentioned River Architects came in and did a test, an industry standard test, which attempts to basically pressurize the building, and you can tell how tight your building is, right? If there's a lot of leaks, you'll see that. If it's a pretty tight building, you can blow air into the building and actually measure that pressure sort of building up in the building. Like it's like blowing a balloon up a little bit, right? And you have a balloon with a bunch of holes in it, it's not going to pressurize. So they did that and noted a few specific areas as well that we wanted to address, where we know that there are essentially holes in the balloon. So then moving on, there is also some these next few items are, again, addressing the building envelope. The air and moisture penetration is important to make sure that air is flowing in the right way. Modern buildings are pressurized just slightly more than the outside air. So if you're heating your building, the air is very slowly kind of working its way out of the building very, very slowly. But what's going on right now is the air is coming into the building and then moving up. So we want to make sure that the building is tight. There are a few expansion joints. That's just a sort of a periodic replacement of caulk joints and things like that. At the exterior doors, if you walk around, you'll see some, if you look at the double doors, you'll see daylight in between there, and that's not a great thing for keeping a tight building. So just improving some door hardware and blocking up some of those holes. The windows, so on the north side of the building in particular that faces the lake, there over the years have been observed some leaks in those windows. So we want to look at that and make sure that that was constructed properly, and if there's any improvements that need to be made on those windows. We also have seen that over time, some of the glazing, the glass in those windows and in other parts around the building have actually shifted a bit over time, to the extent that in one or two cases, it's actually produced a gap as well. So removing some of those pieces of glass and resetting them properly with setting blocks and things is part of what that's about. Then moving on, there's a little bit of work for downspouts up on the north side to try to manage the water a little bit better there. Then moving to the next page, we have some work on exterior soffits. So the horizontal part, and we'll see these if we look at some of the thermal images, we'll see this very clearly, that when we investigated the building, we found that there was essentially a free flow of air from inside the building out through kind of the top of the building and then out through those soffits. So that's a significant source of air exchange where air should not be exchanging between the outside and the inside of the building. So so there's some significant work to go around that and actually fill in the gaps and treat that area properly. So that it means getting a lift up and taking those panels off and sort of finishing the work that that should be done up there. Then we get into a couple HVAC items here, a little bit of stuff on the heating distribution system, some draft stopping, because as these 3 floors, you know, sort of work together, that, like I said before, the air can heat up and sort of flow up the building and create that chimney effect. And we want to block off as many locations as we can. The HVAC control systems, there's a computerized control system that tells the equipment what to do under certain conditions. And so we want to look at what we call the sequence of operations, which is that just methodical, detailed directions, so that as the building and the HVAC system senses things like indoor temperature, outdoor air temperature, what the mechanical system is doing, it can respond appropriately. And then lastly, we have some heating and ventilation system corrective work, and a few specific items there. We talked a little bit about the controls, sealing up some relief dampers. TAB is called TAB, stands for testing and balancing. So that's another pretty standard type of work that happens in new buildings, and people go into old buildings as well, and rebalancing the ductwork and making sure that the right amount of air is going through the ducts to the right amount of places, and there's a lot you can adjust there to fine tune things. Your glycol water systems that help move heat and cooling around your building just need a little bit of work there as well. A couple more details about that hydronic heating system. So sort of a grab bag of mechanical system control, mechanical system improvements. And then we're picking up a few electrical boxes at the end there. So that is just a very quick explanation of the specific scope items.
Do you want to take a look at the thermal images?
Yeah, that would be great, Michelle. Thanks. So this is what I was talking about up at the Soffit. And so these pictures are taken with a thermal camera. So they're looking at basically the heat, how hot or cold the surfaces are that it's looking at. And so it's kind of intuitive that, you know, the blues and the purples are cooler and the reds are hotter. Okay. So when we look at an image like this, at the top corner, you can kind of see the brick pattern in that purple, right? And as you get up to the top, where that orange starts to come out, that's this air coming out of the building. So most of these pictures were taken during the winter, or perhaps all of the pictures were taken during the winter. So we want to see really nice cold surfaces when we look at a building in the winter. That tells us that the heat is not leaking out of the building and making the outside of the building warm, right? So that's what we look for when we sort of analyze these images. So we see a lot of heat pouring out of that soffit. And I think we've got a couple more like that around the building. If you want to go to the next page, Michelle, thanks. Yeah, so even, you know, in the front there, you can see that. You can even start to read the joints in those metal panels, you know, as those transfer energy through and are leaking right at the top of the brick wall. On that lower picture, you can see the sign, the Mahopac Public Library sign. And that is nice and cold because it is metal and it is, you know, separated from the building. So when you look at images like this, you also want to kind of check and make sure, okay, what we're seeing makes good sense. And moving down, this is actually one of the areas that I think River Architects identified, as they did some thermal imaging as well as part of the study that the board authorized them to do up in that large meeting room. Up in the corner, you can start to see that there, some of the spaces between the joists in the roof, in this case, were not properly insulated. So you see a difference in the amount of heat and cold that's moving through those stud cavities. And maybe this is the last one. Yeah, so we did a little bit more investigation inside, and we poked a hole in the wall kind of near this one, but also wanted to just check. And this is an area where there is, good insulation, and those lighter purple vertical stripes that you see there are the metal studs, and those do transmit, metal transmits, heat more readily. So you would expect a little bit of colder temperature coming through those studs and warmer temperature between the studs. That means that there's insulation there and it's doing its job, and it's keeping the heat inside the building and keeping the cold outside the building. So yeah, thermal images are one good tool we have to try to figure out where the best efforts should be made to improve the situations that you're seeing.
Okay, click that. Okay, oops, I don't have to do that anymore. Okay, that's good. Bob, did you have anything to add?
Yeah, just to expand on a few things. So as everyone knows, there's several different ways you can insulate a building or insulate a house, a home, a structure. So your building has basically been bad insulation. It's fiberglass, and the evidence shows that we want airflow. All right, so you have a building, whatever size it is, you want to have airflow. But there's two different types of airflow. And I'm going to try to be in a layman's term. If we get external airflow, we have penetration. And that's what your building's showing, is that we have air that's going from inside the building, outside the building, and air that's outside the building, inside the building. You don't want that, okay? Internal airflow we call that circulation. Your HVAC system or your heating system, your cooling system, whatever type of air conditioning you're doing, whether it's radiant heat or baseboard or hydronic, that's going to circulate your air. And we want that. So the biggest problem you have is you have bad insulation that wasn't installed correctly. Okay, now I've been going through your drawings, the new drawings. I'm just about done with a constructability review and what is planned. And my concerns, that last thermo image that you saw was a wall, your typical drywall stud framed wall under a window, and it was purple. And the reason why that insulation is working is because that's your typical 16 on center framing. I think most everyone's pretty familiar with what I'm talking about. When you buy bad insulation, you can buy it in 14.5 inches and 22.5 inch frames. You put them in place, they stay there. They stay where they're supposed to be. Now and that's how it performs. You don't want that insulation packed tightly. You want that in bad insulation. You just want to make sure that it is cutting down on airflow, external penetration. And that's how the heating, your thermal, but part of the assembly works. So with that being said, you look at many parts of your building, expansion joints where the brick's moving, some window glazing, some seals and doors and windows, as everyone has experienced. All those little things add up. It's like change out of your pocket. Every day, a little more, a little more, a little more, a little more, and it taxes the building. As I look at it, that is probably the bulk of your problem. I think you all know that. And then the balancing is very important, but you're never going to be able to balance your system until you take care of your thermal envelope. And what happens with the balancing is that the system, an engineer designs a system to wash the windows, to wash the perimeter of your glass, your perimeter of your doors with either heating or cooling. In the summertime, you want the cold air to fall in front of the windows, so it keeps the penetration of the sun's rays from heating up the building inside. In the wintertime, it's just the opposite. You want the heat to rise or fall, depending on how it's set up in front of those windows. When I walked through the building a couple of years ago, when I first started looking at this, I noticed that some of your supplies and your returns, at the time, I didn't know if they were in the right spot because I'm walking through a building. I don't know if that's how it was designed. I hadn't looked at any plans. I just found it peculiar that some of your supplies weren't on the perimeter of the building where most people, you walk into your house, if you have baseboard heat, that baseboard heat's on the outside, on your outside walls. It's the same theory. So that just brought me a little bit, I was a little curious about it. Jumping back and looking into the plants, my concern with what we're doing is, and I'll talk to Chris about this, and obviously I spoke with Louis, we met on this yesterday, my business partner, Lou Rodriguez. Your columns that are around your windows, we're calling to open that up and put fiberglass insulation back in there. I believe, and I could be wrong, once again, I wasn't around this project 20 years ago. I don't think the fiberglass insulation might have been installed correctly, but because of the size and the dimension and the structure of those columns, it might not have stayed there. I don't know if you understand what I'm saying, is when you usually, you put things, fiberglass insulation is usually fit with a friction. It sits in and it holds in place. You can staple it, you can tape it, you can use stays. There's some mechanical components that you use to hold it in place. I believe, I think, I assume, is that it's failed because it wasn't installed correctly. They might have put it in place, but I don't think they attached it correctly. And it's all those little things. It's all the little gaps, all the little movement, all little failures that's taxing your heating and cooling system. Now, once again, the heating and cooling system could be another issue, but if you go outside in the wintertime and you don't have a hat on and a good coat, I don't care how strong and healthy you are, you're going to get cold. And basically, this simplistic part of this is that, I think that's your biggest problem is the outside of this perimeter. I believe the reports, the history of the failures that you've had, and what it's cost you to run this place. I think that looking at it, and I'll talk to Chris about this, I just think that we should be looking at possibly discussing the insulation spray foam.
We can think about the specifics of that.
Right, different types of thermal protection. You look outside your building. I was in Michelle's office with Gunther. I don't know.
Yes.
Right, and we, you can just feel it. This isn't really a very difficult thing to understand. I know you all have a good grasp for it. You've all been living with these problems, but that's what my 2 cents here is. Just it's I always equate it to losing weight. Everybody knows how to lose weight. The hard part is losing weight. The problem you have with your building is, we've got to take care of the insulation, and then we can look at all the other matters. And
well, Bob, you brought up the fact that which is right on, and one of the things that we looked at, the fact that until your building envelope is solid and built built properly and doing what it's intended to do, the mechanical system can't really do what it is intended to do, right? So we got to fix that envelope first. And one of the many studies that Michelle mentioned from OLA engineers was a kind of an engineering solution, like let's give you more heat, and that's one way to approach it. And there may be, like I said, some adjustments to be made once we get the envelope performing properly, and then hopefully, we hope that a lot of your mechanical systems will then sort of fall in line and be able to function as they were originally designed to do.
Exactly. The testing and balancing, and as everyone knows, so heating and cooling is purely mathematics. The height, the size, the volume of the room with the exposure of the glass is going to give us a formula for BTUs. Now, what happens is if it's not balanced, and just think about it this way. If you walk into your kitchen in your house and you're pumping heat at one end of the kitchen and you're returning that heat, if it's, it's ventilated. So it breathes, it blows out hot air and it sucks in air to recirculate that air and either cool it or heat it, depending on the time of the system. If the room's not balanced, then it's going to have a very difficult time executing the math. It could be short cycling. The hot air might be coming out of a supply and being pulled, the majority of it being pulled right to a return. And it never gets a chance to heat the components of the room. Or in the summertime, the same thing. Your cooling air might come out and be short cycled, but be returned, because heating and air conditioning works with just like your lungs. You're blowing it out, you're inhaling it, and it just circulates it. So that's why it's very hard to get the proper execution of a heating system or even register if it's working right, if there's so many outside factors that are affecting it. And once again, it's a long-winded way to say, this isn't working, as you know. So I think the biggest components there are the testing and balance is very big, but before, we have to do this in concert. There's many aspects of the building. When you go back to the first slide where it shows a bird bath, a puddle of water in your parking lot, my assumption is that that parking area was was to increase porosity. So your blacktop is impervious, no water goes through it. I'm assuming there was some type of engineering that was done that said, hey, you don't have enough subsurface drainage systems for your parking lot. All right, because what happens is you take a piece of land that has grass on it and trees, and now you want to you're going to change that surface. When it rains, the water goes into the ground. But now you're going to change that system and you're going to put in a parking lot. You're going to put in impervious soils, right? Our components, blacktop. So I'm assuming those parking lots those parking spots were there. That was designed that way to let the water go through. And they was put together so it doesn't, those honeycombs are so it's not muddy, so people can pull on there. The water goes through because of engineering or maybe some type of green aspect. And now what's happened is it's not working, whether it's filled up with clay over the years from sanding and salt and from pollen, from leaves, organic matter. So that has to be, that has to be addressed. It's just, this is, you see components here that I think weren't done correctly. And then there's a matter of, it's things that have, some time. There's a lot of areas where water has done a lot of damage to the outside of your building. I hope that helped.
Yeah, thank you very much. Thank you, Chris. Thank you, Bob. Does anybody have any questions for either Chris or Bob?
Would you explain, Bob, what your role will be to the public? I know people wonder. I know you're talking about being the GC, the general contractor, but explain in like you always say, layman's terms, quote unquote.
Okay, so
you're going to be in the building when these contractors come in, when the bids are finally. Well, why don't you tell them what you're really going to do, because we want this project to last 30, 40 years. This is not going to be done 5 years from now, 10 years from now. This is going to be done right, but go ahead.
So in layman's terms, Frank, technically in my company, my partner Lou Rodriguez is a CM and I'm a GC. Okay, and the difference between the two is there's a little bit of a difference from it, but the gist of it is the same: quality control. And what we do right now, my firm, the Palumbo Group, we build public buildings and schools. We're doing the work at Mahopac High School now, that district. And what we would do is we work with an architectural firm, engineering firm, which is obviously Tetra Tech and Chris, and we've got a long-standing relationship with many of these firms. And what happens is we go through the design process and we come up with a game plan. And as you know, it takes a bit of time. Then we execute that plan. What we would do is we take those plans and we break them up into different components, and we go out and solicit all the people that are going to do the work on it. That's a long process. We take it, and once we solicit all these bids, we put together a game plan, a phasing plan, a financial plan, and how it's going to be executed. We man the job, and we're on site supervising all and orchestrating all these components. And I don't want to scratch at a wound, but our success, you wouldn't have had these failures. The simple failures of the insulation. And once again, I'm not saying that it was installed wrong. I'm saying that, you know, the quality control to all these little components, that's what we do. We manage and drive the work. We negotiate everything. We schedule everything. We make sure there's safety. We go through the whole submittal process. We implement your wishes with the architectural plans that are developed and make sure that you get what you paid for. That's what we do. I know it's, once again, it's layman's term. And the difference between my partner and I is that he's very eloquent at these type of meetings. And I'm not. I'm a contractor. I'm the guy that you want on the job Monday morning at 6:45. You know, I'm a little forceful and a little brash, but I'm the guy that drives the job, and that's what our people do. Louis is the guy that does the exact same thing, but he just does it with a lot more panache than I do.
Thank you, Bob. That clerk of the works is so critical, and you just exude that kind of quality the way you're speaking. I know you're going to be around and make sure we get the best bang for the buck, and the job is done right and done well and long lasting. Thank you. I don't know if anyone else has a question. No?
Nope. Okay, thank you very much. I just want to thank everybody for coming. And I just want to remind you, we just have 3 things to ask of you. The first one is to please come and vote on June 7th and to encourage your family and friends to do so. It's June 7th at the library, and it's going to be from 7 o'clock a.m. through 9 p.m. Also, if you have any questions or anybody you hear in the community, you hear people talking about the project, asking questions about the project, please feel free to direct them to me or to one of the board members to ask their questions. We really want to make sure that everybody gets the right information. We're being very transparent about this process, which is very important, and we want to make sure the information, everybody's questions are answered and they get the appropriate answers. And the third one is, if you are a member of any community group that you think we should speak to, if you could provide us with an introduction, that would be great. So we can go and we can talk to the group. We are going to talk to the Rotary. We're going to talk to the Chamber. I believe we're going to talk to the Italian American Club, but any other groups we would be happy to speak to. So please feel free to reach out to us at the library. And thank you again. Thank you very much for coming. Thank you, Bob and Chris, for your time, and thank you to the board members for your time. And we hope to see you on June 7th. Thank you.
Okay, thank
Great.
you.
Good night, everyone.
Thank you. Good night.
Thank
Night.
you.